Hi guys, Raz here on the beach. You get me. We'll be looking at Pascal's triangle today. So, let's start off by getting you to expand these. So, pause the video and just expand those 5 brackets. Welcome back. I'm guessing you gave up, and you're probably thinking, surely there's a quicker way than this. Like this one's light work. We get 1 plus x plus x squared. And then we do this one, 1 plus x times 1 plus x squared. And we get 1 plus 2x plus x squared plus x plus 2x squared plus x cubed, which equals 1 plus 3x plus 3x squared plus 1x cubed. And then it starts to get a bit irritating. Yeah, so that's what the video is about. Is there a quicker way? Is there an easier way? And I'm glad to say that a man called Louis Pascal created his triangle, called Pascal's triangle. So we create the triangle by simply, actually, before I mention that, let's see what we notice. So if we notice here, those coefficients matched our 1 plus 2x plus 1x squared. You can see we have the 1, 2, 1. And when we did the next one, we had 1 plus 3x plus 3x squared plus 1x cubed. Just notice again, as if by magic, they match these. So if we had to predict the next one, you'd be right in thinking if you bother to expand them all, we got 1 plus 4x plus 6x squared plus 4x cubed plus 1x to the power 4. Yeah? Brilliant. So the way we write the triangle is you notice we just start with a 1 and a 1. And then when we add those two ones together, we get this number. And then we sandwich it between some ones. Then we add the 2 and the 1 together and we get a 3. And again, we sandwich those between some ones. And we then do the same again and we get the 4s. But for some reason I can't add. So we get the 4s, but this time as well, we get a 6. And then we sandwich those 3 numbers together between some 1s. And then we continue in the same vein. So that was x squared, that was x cubed, that was x to the power 4. So up to x to the power 6, this is pretty useful. So let's give a couple of questions a go. So pause the video and give this one a go. Welcome back. So hopefully you found for this one, I've just put my triangle in the corner there so I don't have to draw it again. We should get x to the power 6 will be this bottom line here. So x squared, x cubed, x4, x5, yeah. So what you should get is 1 plus 6x plus 15x squared plus 20x cubed plus 15x to the power 4, 6 for x to the power 5, and then 1x to the 6. Now, let's look at what happens when we don't have an x. So this time, what will happen is, I'll still use the same coefficients from Pascal's triangle, 6, but this time I've got 6 lots of 2x to the power of 1, plus 15 lots of 2x to the power of 2 plus 20 lots of 2x to the power 3 and 15 2x to the power 4, 6 2x to the power 5, and 1 lot of 2x to the power 6. So we've got a little bit of simplifying to do now, because the first one we're going to get 12x, but now we're going to get 15 times 2 squared, x squared, which would have been 15 times 4. So that one's easy. So I'll just do that now. Next one, we've got 20 times 2 cubed, x cubed. So again, that would have been 2 cubes 8. So 20 times 8 is 160. Now it's getting a bit tricky. We've got 15 times 2 to the power 4. So that is 2 to the power 4 is 16. 16 times 15 is 240. 6 times 2 to the power 5, x to the power 5. If you didn't realise this already, when we start doing tougher maths, a little dot means times, because doing a cross, it's quite confusing. Yeah, because we use x quite a lot, don't we? So we have plus 6 times 32. Get the calculator. Got one. 192. I do feel like I let myself down a bit using the calculator, but what you can do. And the last one, 1 times 2 to the power of 6, which is 64, x to 6. And that's that. So let's try a different one now. So now not only is it not a 2x, we have a minus. So actually, I'm going to challenge you to do this one yourself. I'm going to enjoy the sun for a minute, and then I'll be back in a sec. Welcome back. So let's use Pascal's triangle. So I didn't copy it, so I'm guessing I wanted myself to write it. So x squared, so this will give me x cubed coefficients. And then we want x to the power 4, which will be this one. So we want those values. So that means we have 1. The reason 1's on its own is because we have x to the naught. I wasn't very clear about that earlier, so let me put that in. So we have 1 times minus x over 2 to the 0, which obviously is 1, because anything above 0 is 1. Then we have 4 times minus x over 2 plus 6 times minus x over 2 squared plus 4 times minus x over 2 cubed plus 1 times minus x over 2 power 4. So the first term will be 1. And now we can get a minus 4 over 2 x plus 6 times minus x squared will be positive x squared over 2 squared. Then we're going to get a negative cubed is still a negative. So we have 4 times negative x cubed. Oh, I've already done the negative. Over 2 cubed, which is 8. And then the final one is minus x to the power 4 is positive over 2 to the power 4. So we simplify that and we get the answer. What do you notice? Exactly. we have alternating polarity in the series. So when we have a minus sign here, that will always be the case. It will fluctuate positive, negative, positive, negative, positive, negative, because when we do a negative to a power of an even number, it will always be positive, and to the power of an odd number, it will be negative. Hence, we get that. So I think we've got one more example here, which is here. So I'm just going to do this as a worked example because you'll look at this and give it a go and you won't know what to do. So the little trick is we take out 3 to the power of 6, which means we know the final term will be 3 to the power of 6. Yeah, we've just seen. And each term will have a descending power of 3 in there, from 3 to the power of 6, 3 to the power of 5, 3 to the power of 4, all the way down to 3 to the power of 0. So we're going to take that 3 to the power of 6 out. And what we're going to do is expand 1 minus 2/3 of x to the power of 6. That will always be the case when we see something like this. Yeah, well, that's how I'm going to encourage you to do it. Some of you may have learned a little bit and query this, but if you watch this video in its entirety, you'll understand what I'm getting at. So now what we need to do is expand. Let's do it on the other side. 1 minus 2x over 3 to the power of 6. And we only want the first 4 terms, yeah? So using Pascal's triangle, I'm trying to think what the last values were. Let's have a look. We had the 1, 16. It was the bottom one of the bottom layer of the triangle. So the first 4 terms are 1, 6, 15, 20. Yeah? So I'm going to use that. So we will have one lot of minus 2x over 3 to the power of 0 plus, I think I said 1, 5, 16, 20. So 5 lots of minus 2x over 3 power of 1. 16 lots of 2x over 3 squared. And 20 lots of minus 2x over 3 cubed. Let me just double check. 1, 6, 15, 20. Probably should have just drawn the triangle, shouldn't I? Anyway, so if we simplify that, we're going to get 1 times 1, which is 1. So that's our first term. And then here we're going to get 6 times minus 2/3 x. So I'm going to think of it that way, which will give us minus 4x. And then here, actually, I'm going to leave it like that because I've just forgotten what my point was. Here we've got minus 30x squared over 3 squared. And the last one, we've got minus 40 x cubed over 3 cubed. So these signs should alternate from positive to negative. Yes, so this was negative 12 over 3x, and we've got these ones here. So if I write that in, what we're going to have is 3 to the power of 6 times 1 minus 12 over 3x plus 30x squared over 3 squared minus 40x cubed over 3 cubed. Yes, so we only want the first 4 terms, so that will do. Now I need to times everything by 3 to the power of 6. So the first term will be 3 to the power of 6. The next one will be 3 to the power of 6 divided by 3, which is 3 to the power of 5, times 12 times x, plus 3 to the power of 4 times 30 times x squared minus 40 times 3 to the power cubed x cubed. So we can see the denominators now cancelling out that power of 3. And that will always be the case when we do it this way. So now we just get the calculator out. So we've got 3 to the power of 6 is 729 minus 3 to the power of 5 times 12, which is 2916 x, plus 3 to the power of 4, which is 81 times by 30, 2430 x squared, minus 27 times 40, 1080 x cubed. Yes, I'd always encourage us to take that factor out, and you'll see why in a minute. So this will be the end of my Pascal's triangle video. If I haven't edited this, you'll just see the continuation of binomial expansions in the next video. If I've edited this, see you in the next video. Well, there's a lot of waffle. I'm just going to get on with it. So, a lot of you are probably thinking, well, that was an effort. Is there a different way to do this? Or what do we do when the power is bigger than 6? Because I gave up drawing a triangle to the power of 6 here, yeah? Well, we get given something called the binomial series, yeah? So let me get that working back. And we did the first 4 terms. So now let's have a play around with this and see what happens. So it is a formula that is given to you in your formula book. Yeah. We can see that in this expansion, A will be 3 and B will be 2x. And we just plug it in. So it tells us we need to type in 3 to the power of 6. Oh, Jesus. 3 to the power of 6 plus n choose 1. So n is 6 in this case. 6 choose 1, a n minus 1. So a is 3 and 6 minus 1 is 5 times by b, which is minus 2x. That's 2 terms. The next one will be 6 choose 2. The power goes down by 1. The other power goes up by 1. And then we get the next one. 6 choose 3. 3 to the power of 3. And then we will get minus 2x to the power of 3. And so on. So if I put up the calculator, what we should see is, well, that's a bit long, I can't see. We get the same answer. So if I go 6 choose 1, that is 6. And if I do 6 choose 2, I get 15. Now, we know Pascal's triangle. So this would have been 6 choose 0. We know that the coefficients of Pascal's triangle that we just used was 1, 6, 15, and 20. So is 6 choose 0, 1? I think we know the answer to this. Yes. Is 6 choose 3? 20. We know the answer. Of course it is. Yeah. So we can see this formula is more powerful than Pascal's triangle because it works for when the power is bigger than 6. Yeah. So if we type these in, we've got 3 to the power of 6, which we know was that. Then minus 6 times 3 to the power of 5 times minus 2x plus 15 times 3 to the power of 4 times minus 2x squared, and which would be 4x squared, plus the last one, 20 times 3 cubed times minus 2x cubed, which would be minus 8x cubed. So if we put those numbers into the calculator, we will see we get the same thing. Give that a go and just check that it's the case. So your curiosity is satisfied, yeah? But you will do. Yeah, I'll do the second term just to prove it. We've got 6 times 3 to the power of 5 times minus 2. Oops. And we get the same thing, yeah? So a lot of you would have seen that in the AS level. So this is the AS level binomial expansions. Now, bizarrely, our first video is going to help us in the third expansions that is used in A level, because what happens is we get given fractional powers and negative powers. Yeah? So what happens if you type in a fractional power into your calculator? So we had n was 1.5. So if I do 1.5, choose 1. Computer says no. What is that about? Yeah. So when computer says no, so in the A2 expansions, we suddenly have to use the broken down version of the formula, which is here. So we have this explanation of what NCR is given into a formula, and you can see they've then omitted the A plus B bit. We've just got 1 plus X. So now the way we did Pascal's triangle really helps here, because let's just get cracking with this first example. We just have to do what we used to doing. So we have 1 plus n. N is the power. So 3 over 2. Oh, I don't need a bracket, hang on. 3 over 2 times x, but x is 3x. Plus n, 3 over 2, times n minus 1. So 3 over 2 minus 1 is a half. Times x squared, all over 1 times 2. Yeah, which is same as times by half. And we only want the x cubed term, so we need one more. So we have n times n minus 1 times n minus 2 this time. So 1.5 minus 2 is minus a half. All times by x to the power of 3. So that's 3x in our case. Then divided by 1 times 2 times 3. Now we just simplify. So we have 1 plus 9 over 2x plus 3 times 1 is 3 times 3 squared. So 3 times 9 is 27 times 1. All over 2 times 2 times 2. Plus the last one, we have a 3 times 1 times minus 1 times 1 times, sorry, 3 cubed. So that's 3 to the power 4 essentially. So we have 81 but negative. All over 2 cubed, which is 8 times 6. X cubed. Yeah? So this is the formula that we're going to be using in the A2. Now, let's do one more. So, how are we going to do this? You got it. Those of you that have watched the Pascal's triangle video will know exactly what to do, which is we're going to take out the power of 2 to the power of minus 2 from the expression and just figure out this. So we can expand that over here. So we need to, no, that's not going to work. I'll run out of space. So we've got to take out a power of a quarter at the end. And we need to just explain like we normally would. So we have 1 as our first term, plus n, which is minus 2, times x, which is minus x over 2, plus n times n minus 1. So minus 2 times minus 3, x to the power of 2, all over 1 times 2, plus minus 2 times minus 3 times n minus 2. So we have n minus 1, n minus 2, plus x over 2 cubed, all over 1 times 2 times 3. If we were to do another term, which I haven't asked in the question, but I'm going to do just to make it clear, it would be n minus 1, n minus 2, and n minus 3, all over 1 times 2 times 3 times 4, and x to the power 4. Yeah? But we haven't been asked that, so I'll get rid of that. So what we're left to do now is simplify. So I have a quarter of 1. And then minus 2 times minus x over 2 is plus x. Now I've got cancellation here. That 2 cancels with that 2, and the minus cancels with that minus. So I've got a minus x squared, which is x squared. Times 3 all over 2 squared. Yeah? Next one, the last one. Let's cancel out where we need to. The 2 cancels. And the minus cancels. And that 3 cancels. Yeah? So we have a minus x cubed is negative, but times by this negative will make it positive again. I've got a 4x cubed all over 2 cubed, which is 8. And now we can simplify. So now I can multiply that 2 to the power minus 2 that I took out at the beginning here. Yes, which is the same as 1 over 4. So we've got a quarter plus a quarter x plus 3x squared over 16. And then obviously 4 over 8 is a half, and a quarter times a half is an eighth. Boom. So I only wanted up to the x cubed term, so that's it. Job done. Yeah, I hope you enjoyed this sequence of videos that takes us from essentially further maths GCSE into the AS level and then the A level. Yeah, so this is the complete course of the A level at Excel that you'll need to be able to expand binomial expansion. I've been Raz. See you soon.